Welcome to one and all for the fourth session of Unit 4, Construction of CNC Machines in Computer Integrated Manufacturing. So in the last class we discussed about the different types of frictional guideways. So what are the guideways? That is a frictional guideways and anti-frictional guideways. So let us further see in detail about the types of frictional guideways. So the types of frictional guideways are classified into 4 types. One is V guideways. So this is we will find a V channel in these guideways. So the guideways will have a V channels so that the guideways are accurately machined so that this carriage will move along with the V guideways. Then is a flat guideways. So here you can see there is a flat surface on which the guideways is going to move. So next is the dovetail guideways. You can see there is a dovetail guideways over here. So just like your dovetail joint. So this is basically used in any lathe machining operations. So where the compound rest will be mounted on the dovetail guideways. Next is cylindrical guideways. This cylindrical guideways are cylindrical in cross sections. So basically you find this type of guideways in drilling machines, CNC drilling machines and some kind of spindle attachments. We go for this type of guide. Depending upon the requirements of the machineries, we go for different types of frictional guideways. So what is V guideways? So here you can see one of these V guideways, there is a V. The angle of V will 55 degree in some cases. In some cases it is 60 degree. So this is a V guideways. So both the surfaces are accurately machined so that the slide can move easily. One of its advantages is that parallel alignment with the spindle is not affected by the wear. So here it is not affected by the wear. Next is it automatically maintains alignment. These guides have advantages of automatic adjustment of play due to gravity. So it will automatically adjust if there is any small kind of jerk motions or stick or slip effect can be maintained easily without any kinds of defects. And this V guideways have a wedge type of action which always keep the surfaces in contact. There is no clear chances of trapping of chips and the foreign particles in the contacting surfaces. So here the guideways are such a way that so the chips will flow automatically without any obstruction. These guideways is difficult to manufacture. Why these guideways are not maximum? They will think about this is that there is a problem in this guideways. It is difficult to manufacture because the high rate of friction and load bearing capacity is very low. It cannot withstand maximum load. So because as a carriage has to withstand the very high load due to cutting speed and feed. So it has load bearing capacity and due to high frictional rates. This will have very difficult for us to use in CNC machines. Next is flat guideways. The flat guideways have better load carrying capacity than V guideways. That is why because it has a greater surface area of contact and load bearing capacity is very high. Friction is very less compared to that of V guideways. I think this is a very good guideways. Flat guideways can be used in industries today. In order to reduce the clearance due to wear, gips surfaces are prospering heat treated and ground to a very high accuracy. Usually we use gip keys in order to maintain the common clearance between these things. Next is dovetail guideways. These dovetail guideways are more compact and simple. So you can see here the angle of dovetail guideways over here. So generally, this type of guideways is cut in form of dovetail gips and it provides a contact surfaces to adjust the play. So this type of guideways are generally used in CNC machines. And these guideways are generally used for drilling milling machines as well as grinding machines and used in lathes also. The main advantage of these guideways is that the main advantages what we found in this guideways is that so they can be easily manufactured compared to the difficulty of manufacturing V guideways or some other kinds of things. So this session I am going to end at this point. Dear students, thanks for your patience listening on this session 4 of Unit 4 of Computer Integrated Manufacturing. Thank you.